So let's talk about standard form of a linear equation. So we've looked at slope-intercept form and point-slope form already. So standard form is yet another way that you can write linear equations. Remember, a linear equation is just going to have an x and a y in it as the variables, and then other numbers somewhere. And the way that it's written kind of tells you a little bit more about that equation, or more specifically, about the graph of that line. So standard form is when you have this equation, ax plus by equals c, where a, b, and c are just numbers. Okay, it can be any number, any real numbers, as long as a and b are not both 0 at the same time. I want you to recognize that in this equation, the x and the y variables are both on the left-hand side of this equation, and c is on the right-hand side. If I were to give you some examples here of equations in standard form, we could have 3x plus 2y equals 12, negative 7x plus 8y equals 5, 1.2x minus 6.3y equals 7.9. Because decimals are still real numbers, you could even have fractions in the place of a, b, or c. So the key here is that as long as, if you look at your equal sign, as long as the variables are both on the same side of the equation, it's standard form. So we have x and y on the left, x and y on the left, and x and y on the left side of the equal sign yet again. So all three of those equations are in standard form. So what we're going to do is look at several different equations that are written in standard form today. We're going to learn how to find what are called the intercepts of the equation. So, or the intercepts of the line. We'll look for the x-intercept and the y-intercept, and then we'll be able to graph the equation of that line using our intercepts. So here's how we graph. So your question or main idea will be the steps for graphing. How to graph. So take a minute to copy these 3 steps down. You can pause your video and resume when you're ready. All right, so step 1 says to find and plot the x-intercept. Step 2, find and plot the y-intercept. And step 3, draw a line through the 2 intercepts. So basically, we're going to end up finding the x-intercept and plotting it on the x-axis. Say it ends up being right there, which I think is 7 or around there. The y-intercept, again, I'm kind of making these numbers up, but let's say the y-intercept is 5. I put a dot right at 5 on the y-axis. And then step 3, I just draw a line through my 2 points to indicate all of the possible solutions to the equation. We just happen to find 2 of them, one at the x-intercept and one at the y-intercept. All right, so I'm going to go ahead and go through this example with you. And it says to graph 2x plus 4y equals 12. Now notice when we talked about the x-intercept, it said x comma 0. Okay, any ordered pair on the x-axis, if we use not just the value, the number, it would be the ordered pair where it's the x value because it's moved left or right from the origin, but the y-coordinate is always 0. For example, on the left-hand side, it could be negative 4 comma 0. But that y-coordinate is always, always, always going to be 0. So what we can do is we can think about, well, what if this y was 0? Well, 4 times 0 is just 0, essentially canceling that out. So what we're going to do is we use this thing called the cover-up method. And I have this rectangular box, but you could really use the end of your pencil, your pinky. You could use, tear off a little sheet of paper. All we're going to do is we're going to say, all right, if y is 0, that 4y is gone. It's not even there. So all I have left is this equation, 2x equals 12. Well, that's an equation with one variable, which we can solve. We just use division. X equals 6. So when y equaled 0, x equaled 6. In other words, 6 comma 0 is the x-intercept. I could then plot that on my graph by going to the right 6 units, and I don't go up or down at all. because my y-coordinate is 0. That makes it right on the x-axis. Now, if I want to find the y-intercept, basically do the exact opposite. I say, okay, that means x has to be 0 because any ordered pair on the y-axis, I don't go left or right, meaning the x-coordinate must be 0. I say, all right, well, if the x-coordinate is 0, 2 times 0 is 0, that's gone. Now I solve what's left. 4y equals 12. So it looks like I'm going to have to divide by 4 to get y by itself, and I get y equals 3. So when x was 0, y was 3. That's one solution to this equation. I can then plot that y-intercept on the y-axis at 0, 3. I now have 2 points, and from last year in geometry, hopefully remember that you can make a line with any 2 points. Just remember to put arrows at the end. And that's how we graph a standard form equation using the intercepts. If you need to, pause the video to copy any of this down. Let's take a look at another example. This time we're just going to find the intercepts. We're not going to worry about actually graphing. If I want to find the x-intercept, I cover up the y, and I solve the remaining equation. Negative 4x equals 20. I use division to solve, and I get x equals negative 5. So my intercept, and I'm thinking about my numbers, the x-coordinate, which always goes first, was negative 5, and that was because my y-coordinate was 0. If I want to find my y-intercept, I just slide my box over using the cover-up method, and I solve what's left. Negative y equals 20. Well, remember, negative y is really negative 1 times y. So if I want to solve this for y, I divide both sides by negative 1, and I get y equals negative 20. So as an ordered pair, remember x goes first. X must have been 0 because I covered it up, and I got a y-coordinate of negative 20. So there are my 2 intercepts. Feel free to pause this to copy any of it down. All right, our third example, this time we're going to find the intercepts and graph. So we have x minus 3y equals 9. Let's start with the x-intercept. If I want to find the x-intercept, I cover up the y. In other words, I make it 0. Y is 0. And now I want to figure out what the x value would be. Well, it looks like x is already by itself when I do that. It's just 9. If I want to find the y-intercept, I move my cover-up box over. I make sure that I don't just cover up, I only uncover 3y. I use that symbol as well. It's technically negative 3y there. So my equation is negative 3y equals 9, because x was 0. I solve this equation using division. Divide both sides by negative 3 is going to make y equal negative 3. My y-intercept is at the ordered pair 0, negative 3. So I plot my x-intercept at 9, 0. I plot my y-intercept at 0, negative 3. I graph my line by drawing a straight line through the points and extend with arrows. Feel free to pause and copy down this information before moving on to the next example. All right, our last example, we have negative 3x plus 5y equals negative 10. We're going to find the intercepts. We're not going to graph here. Finding the x-intercept, let's cover up the y variable and solve the remaining equation that we can still see. Negative 3x equals negative 10. It looks like we just have to divide once again. Divide by negative 3 on both sides to get x by itself. And when I divide a negative by a negative, I get a positive. And 10 divided by 3 is 3.3 repeating, or 3 1/3. So the x-coordinate was 3.3 repeating when the y-coordinate was 0, because it was covered up. I move my box over, remembering to uncover that symbol, the plus or minus symbol, because that's part of the 5y. And I solve the remaining equation. 5y equals negative 10. I divide by positive 5 on each side. And and I get y equals -2. So we covered up the x, so that was 0, and we got a y coordinate of -2 as the intercept. All right, so one other thing we want to do a standard form is actually see if we can rewrite the equation in slope-intercept form. Remember when we talked about slope-intercept form a few lessons ago? That meant that y was by itself. Y equals mx plus b is that slope-intercept form. So we want to try to transform this equation and rewrite it, basically getting y completely by itself. Think of this as a literal equation in which we're solving for y. So in this example, if we want to solve for y, we need to move the term that has the x in it to the other side, and then we're going to have to divide by the coefficient of y. So in this example, to move this entire term of negative 3x, we're going to want to add 3x on each side. So we start with that. Now, I know that I can't actually add 3x to -10 since they're not like terms, but we can rewrite it as either -10 plus 3x or positive 3x minus 10. And I just bring down the 5y. So now to get y completely by itself, the only step we have left to do is to divide by 5 to undo that multiplication. Now, when you divide by 5 on the left-hand side, we have to divide by 5 on the right-hand side. And instead of saying the whole thing divided by 5, what I'm going to write is each part divided by 5, because it really has the same meaning. This is just easier to simplify, though. So on the left-hand side, 5 divided by 5 is 1, leaving us with just y. 1 times y is y. Then for the x term, we have 3x divided by 5, which we can just use the fraction part, 3/5, to represent the coefficient of x. And when I divide the constant part, 10 divided by 5, we get 2. So here's my equation in slope-intercept form, where my slope of the equation is 3/5, and my y-intercept of the equation is -2. So we started with the equation in standard form. We were able to transform it to get it in slope-intercept form. Just get y by itself.